Alright guys, new topic today called similar shapes. Alright, I think similar shapes is best learned through jumping straight into a question, and I'll explain what similar shapes are as we go along. So let's have a look. Triangles ABC and DEF are similar. Okay, first of all, why are they similar? Well, basically, DEF is just an enlarged version of ABC. Okay? Work out the length of DF. All right. Now, similar shapes have a really important characteristic, and the characteristic is this. The corresponding sides have the same scale factor. Corresponding means matching. So what that means is this side corresponds to this side. This side here corresponds to this side. And this side here corresponds to this side here. Okay? So if we're able to find out the scale factor of these two sides, since they're similar, we can apply the same scale factor to these two sides here to find DF. Okay? So let's find a scale factor between 5 and 20. How can you find a scale factor? Well, there are three ways you can find a scale factor. You can write it as a number, a fraction, or a ratio. Okay? I like to use the number because it just makes the most sense. All I think about is how many times bigger is 20 compared to 5? All right? An easy way of doing that is just simply doing 20 divided by 5. So 20 divided by 5 is 4. So the scale factor is times by 4. 5 multiplied by 4 makes 20. Therefore, if the scale factor is times 4 for these two sides, the scale factor between AC and DF is also times by 4. So what we can do is we can do 6, and since we're getting bigger, we're going to multiply by 4, which is going to be 24 centimeters, and that's our answer for DF. Next, find the length of BC, which is this side here. Well, since they're similar shapes, if the scale factor of this side is 4, and the scale factor of these two sides are 4, then the scale factor of these two sides must also be 4. Now, since we're going from a long side to a shorter side, instead of doing 22 times by 4, we're going to do 22 divided by 4, which is 5.5 centimeters. And that is our answer to the first problem. It's just realizing that in similar shapes, all the corresponding sides have the exact same scale factor. So if you're able to find the scale factor of one set of corresponding sides, you can apply the same scale factor to the other set of corresponding sides. And you can just simply find a scale factor by thinking, how many times bigger is 20 compared to 5, which you can just do by doing 20 divided by 5. So it's times by 4. All right, guys, next problem. The diagram shows 3 similar rectangles. Work out the size of side X. Well, the rectangles are similar. Therefore, this rectangle and this rectangle have the same scale factor. This rectangle and this rectangle have the same scale factor. And this rectangle here and this rectangle here have the same scale factor. So to work out the size of X, I can perhaps use a rectangle A and B to help me. So let's look at these two corresponding sides because we have both of those lengths. So how many times bigger is this length than this length? Well, I'll just do 12 divided by 4 is equal to 3. So the scale factor between A and B is multiplied by 3. So if I want to find this length, X, I can simply just get this length. And since I'm going from the bigger rectangle to the smaller rectangle, instead of multiplying by 3, I'll just divide by 3. So 18 divided by 3, which is 6. So our size of X is 6 centimeters. Okay? Next, work out the size of Y. Okay? So you can either use, so now we have to use rectangle C. So we can either use rectangle B to help us find the scale factor, or rectangle A to help us find the scale factor. So why don't we use rectangle B to help us find the scale factor? Well, I know these two sides, 12 and 15. So let's find a scale factor between rectangle B and C. So first of all, what you can't assume is that oh, since the scale factor between A and B is 3, that the scale factor between B and C is also 3. You have to find out a new scale factor. So how do I get from 12 to 15? Well, remember guys, just divide. 15 divided by 12 is going to be, I think that's 1.25 if I'm not mistaken. 1.25. So our scale factor from B to C is times 1.25. Now, since I have this length, 18, and I'm getting bigger, I'll simply just multiply 18 by 1.25, and that should be our answer, which is going to be 22.5. And that's our answer for Y. You could have also used rectangle A to help us find the scale factor between these two. All right, so we could have done 15 divided by 4, which is 3.75. So the scale factor between A and C was multiplied by 3.75, and then we can get our 6 and multiply it by 3.75, which would have been hopefully 22.5. Yes, 22.5. So you could have used rectangle B or rectangle A to help you solve this problem. All right, guys, next question. BE is parallel to CD. They give us all the lengths, and find the length of E to D. Okay. Well, let me tell you something. This is an example of a similar shape question. Even though, like in the previous two questions, that the shapes were separate, here the similar shapes are inside each other. So I can see one big triangle and one little triangle. Now, if one shape, here's a little fact, if one shape fits perfectly inside another, they are similar. Okay? And the best thing to do, guys, is to draw out both these shapes separately. So let's first draw the small triangle ABE. ABE, 9 and 6. And then let's draw the big triangle ACD. C to D is 7. A to C is 9 plus 3, which is 12. And that's it. Okay? And we have to find the length of E to D. Okay. Well, how can we find this length E to D? Well, probably the best course of action is to, one sec, find the length of A to D, and then subtract it from the length of A to E, and that will leave us with the remaining section which is X. So we need to find the length of A to D first. So, since we know, guys, that this small triangle fit perfectly into the big triangle, that they're similar, we know that all the corresponding sides have the same scale factor. These two sides have the same scale factor as these two sides, which have the same scale factor as these two sides. So how can I find this missing side here? Well, perhaps we can use these two sides because we know both of their lengths. So how does 9 fit into 12? Well, remember guys, we can just do 12 divided by 9. Because the opposite of multiplication is division. So 12 divided by 9 is 1.3 recurring. So basically, the scale factor of all the sides will be times by 1.3 recurring. So now, if we have a to e, to find this side, a to d, since we're going from a smaller side, or a smaller shape to the bigger shape, we'll multiply 6 by 1.3. Which is going to be 8. So we know from A to D is 8 centimeters. And from A to E is 6 centimeters. So the remaining length from E to D is just 2 centimeters. Next, find the length of B to E. Well, we can use this side here corresponds to this side here. So since we're going from a bigger shape to a smaller shape, we'll do 7 divided by 1.3. Which is going to be 5.25. And that's how you do it, guys. All right, guys, next question. AB is parallel to XY. The lines AY and BX intersect at P. Yep. AB is 6. Yep. XP is 12.5. And XY is 15. Work out the length of BP. We want to find this side here. All right. So I got like some ribbon, like a bow tie shaped object, and I got to find the length of B to P. How do you do this, guys? Well, what you have to recognize is that perhaps these shapes are similar, and if we realize that they're similar, we can find the scale factor. But how can we prove that these shapes are similar? Because it doesn't tell us that the small triangle is similar to the big triangle. How do we prove it? Well, you have to know one really important fact about similar shapes. It's this: all the angles are the same. So for example, if I drew two triangles, and this angle is 30, this angle is 30, this angle is 60, or 70, this angle is 70, 100, this must be 80, 80. Since the angles are the same, we know that these two triangles are similar. But in this question here, they don't provide us any angles. So how do we know? How can we check similarity if we don't know any angles? Well, we have to use our angle facts and angle rules. And here's the first rule, guys. If you have two lines which are intersecting each other like this, the angles opposite each other are always the same. So this angle is the same as this angle, and then this angle will be the same as this angle here. So I can see this in this shape here. We have two lines intersecting each other. So therefore, this angle is exactly the same as this angle here. Okay, the next rule, guys, is our parallel line rules, okay? There's another fact you have to know to help you solve this problem. It's called the alternate angle rules, aka the Z rule. Let's say you have two parallel lines, and there's a line that's drawn across, so it makes the two lines makes it look like a Z. The angles inside the Z are always the same. Can you see a Z rule in this question? How about this? Therefore, what do we know? Which two angles are the same? We know this angle here and this angle here must be the same. So I'll label that as the green angle. So these two angles are the same. And then I also see a Z on the other side. Oops. So this angle here must be the same as this angle here. Let's call this the purple angle. So this angle here is exactly the same as this angle here. So since both these triangles have matching angles, we know that these two triangles are similar. Okay, so what you can do now is you can either draw it out separately, but they're pretty much separate already. So let's go ahead and find out how to find this side by using our scale factors. Now the key here is being really careful about which sides correspond to which sides. Okay, and I like to do it with these angle colors I've drawn. So the side 6 is in between the purple angle and the green angle. So this side must correspond to which side on the other triangle? It's also the side which is in between the purple angle and the green angle, which is this side. So these two sides correspond to each other because they're both in between purple and green, purple and green. So how do I get from 6 to 15? 6 times what makes 15? That's pretty tricky. We'll just do 15 divided by 6. We'll do the inverse, which is going to be 2.5. So we know the scale factor from the small triangle to the big triangle is times by 2.5. Now, our missing side x is in between black and green. So let's find the black and green side here. Well, it's this side here. So we know that these two sides are corresponding because they're both in between black and green. So we can do 12.5, and since we're going from the bigger shape to the smaller shape, we'll divide by 2.5. And our answer is 5. BP is 5. All right, guys, next question. So I'm given this shape over here. I'm given some sort of ratio. AB to AC is 1 to 3, and we're trying to find the length of C to D. Okay, straight away, guys, I know this is a similar shape question because this small triangle fits perfectly into the big triangle. So for sure, I know this is similar shape. So let's draw out both shapes. So you always want to separate it. So the big triangle and the little triangle. Let's fill in the gaps. So A, B, E, A, D, C, boom. B to E is 4, A to B is 5, and C to D is X. So what we could do is first look for a scale factor. The issue is, how do we find our scale factor? Because we need to find our scale factor so we can see what we have to multiply 4 to make X. But unfortunately, we don't have any other corresponding sides. We know this is 5, but we don't have this side. And we don't have either of these two bottom sides. So what we can do to help is look at our ratio. The ratio of AB to AC is 1 to 3. Now, the trick to understanding this ratio is to interpret it. And how do we interpret it? Pretty straightforward. For every 1 centimeter of AB, AC is 3 centimeters. Because you can see here, AB is 1 centimeter and AC is 3 centimeters. So we can write it out. For every 1 centimeter of AB, AC is 3 centimeters. So what can we deduce from this ratio? Well, how many times bigger is 3 centimeters than 1 centimeter? It's 3 times bigger. Hence, our ratio, our scale factor is times 3. And that's our scale factor. So now, if B to E is 4, all we have to do is 4 and times it by 3 to make X, which is 12. So CD is 12. Then we need to find the length BC from here to here. Well, like before, what should we do? Let's find the length of the whole thing from A to C, and then subtract it from A to B. And that should give us the remaining section which we want. So we need to find the length of A to C. So all we do is say, okay, I know this corresponding side is 5. And since we're getting bigger, I'll just times it by our scale factor, which is 3, which is 15. So A to C is 15. So 15 minus 5 is 10. And that's our answer for BC. So all we used, guys, was our ratio to find the scale factor. Because 3 is 3 times bigger than 1, the scale factor is clearly 3. Similarly, if the ratio was, 1 to 4. 4 is 4 times bigger than 1, so the scale factor is 4. Or, for example, 2 to 5. How many times bigger is 5 compared to 2? You just simply divide. You just do 5 divided by 2, which is 2.5. So our scale factor would be 2.5. So that's how we can use our ratios to help us with our similar shape problems. Okay, guys, and here are some questions to practice everything you have covered so far. Give it a shot, and if you have any questions, just let me know. Thanks. Alright, guys, a challenge problem. Let's have a read through. A frustum is made by removing a small cone from a large cone, as shown in the diagram. Work out the volume of the frustum and give your answer to 3 significant figures. Let me see my calculator first real quick. So, what's a frustum? It's made by removing a small cone from a large cone. So we have this massive large cone, and we're taking away the small cone. So what's left, this section here, is called our frustum, okay? So we have to find the volume of a frustum. So volume of frustum. How are we supposed to go about this problem? Because if I look at my formula sheet, there's actually no formula for a frustum. So how are we supposed to do this? Well, one way we could find the volume of this shape here is to find the volume of the entire cone first. And then I can subtract it by the volume of the small cone. And what's remaining should be the volume of our frustum. So to find our frustum volume, we'll get the volume of the big cone minus the volume of the small cone. So let's start with the volume of the big cone. And we're very lucky that we are given a little formula sheet here. To find the volume of a cone, it's 1/3 pi r squared height. So let's do it. Let's find our volume of the big cone. So it will be 1/3 pi the radius. So for our big cone, the radius is half a diameter. So it's from here to here. So half of 30 is 15. So r squared times the height. The height of the big cone is 40. And that will give us the volume of the big cone. So let's put that in our calculator. 1/3 times pi times 15 squared times 40. And that gives me a volume of pretty much centimeter cubed. All right. So that's the volume of the big cone. Now we have to find the volume of the small cone. But I notice a problem. We look at the small cone. So it'll be 1/3 pi. We don't know what the radius of the cone is. If we don't know the radius, it's going to be impossible to find the volume. So let's just leave the radius as r squared. And the height, we're lucky, it's 20 times 20. So somehow we have to find the radius of the small cone. And how are we supposed to do that? Well, in the 3D shape here, I like to try and make it a bit more 2D. Okay? So are you able to spot any sort of 2D shape in this problem? How about this? We look at our big cone. Our big cone can be split into like a little triangle. And then our little cone has a similar triangle, which fits perfectly inside. Like that. And since the little triangle fits perfectly inside the big triangle, they are similar shapes. So perhaps we can use similar shapes to solve this problem. So let's go ahead and draw out both our triangles. So I'll have my small triangle and our big triangle. And let's fill it out. We know the length of the big triangle is half of 30, which is 15. And we know its height is 40. Now, for the small triangle, we know the height is 20. And we need to find the length, because the length is basically the radius, which is what we need to find our volume. So x. And there we go, guys. Once we turn this 3D shape into a 2D problem, it becomes very clear we have created some similar shapes, and our scale factor is pretty easy to find. These two sides are corresponding. How do you get from 20 to 40? Pretty easy, times by 2. So our scale factor is times by 2. So if we know this length is 15, should we times 2 or divide by 2? Well, since we're getting smaller, we'll divide by 2. So 15 divided by 2 is 7.5. So x is 7.5, which is pretty much our radius. So now we can replace our r with 7.5. So minus, oh no, we'll solve it first. So we can replace this r with 7.5. So 1/3 times pi times 7.5 squared times 20, which is going to be 1178.062. So the volume of the big cone is 9,000. The volume of the small cone is about 1,000. And to find the volume of the frustum, we'll subtract them. So 9424.5 minus 1178.062 is 8246.438. And we'll round this to 3 significant figures, which is going to be 8250 centimeters cubed. And that's our answer to our challenge problem. Okay. On the next page, here are 2 problems that you could practice. All right. Thanks.